Hi, and welcome to another STEAM Kids virtual classroom here at the Colorado Model Railroad Museum. I'm Michelle Kemp, my executive director, and with me today I have Captain Krueger. Captain Krueger, you're actually a volunteer here too.
Yes, I am.
He's actually our locomotive manager. He fixes all the locomotives, so not only is he a pilot, he's also a railroader. So today we're going to continue our talk about flight. Last time you talked about how a wing works, or how lift works. And so I think we should kind of go back and go over that again, and then we'll make our crafts, and we're going to talk a lot of planes today. So first I need to thank our sponsors, Union Pacific Foundation. Thank you for sponsoring this and all of the kit supplies for all the kids doing this with us. And thank you to Greeley Station for the production. So Captain Krueger, can you give us an overview of flight again?
Okay, real quickly, last time we talked about the shape of the wing. And in most wings, the bottom is flat and the top is curved. And the whole idea is the airplane is pushed through the air. That creates a lower pressure on the top because the air accelerates in the top of the wing, right? Going faster than the air on the below the wing, and that creates less pressure in the top and creates lift. So we demonstrate that again. So I have this piece of paper. So the static pressure on this piece of paper is all equal. Top, bottom.
It's just sitting here.
It's just sitting there. Now, if I take this, and I'm not going to blow it from the bottom, I'm going to blow it from the top, right? So I'm going to increase the flow of air over the top of the piece of paper. And notice what happens. So what I did, it lifted, because I decreased the pressure on the top of the wing. If you want to call this a wing, lowered the pressure, and that caused the piece of paper to lift. And that's exactly what we do when we fly an airplane.
So we're going to do a few crafts and talk about some other different parts of flight. In your kit, you have 3 pieces of paper that could be whatever color together, clipped, and you have 2 straws. So if you want to pull them out, one of the pieces of paper is for a different lesson, so you'll need to take that out and just set it aside. So what we need for our first craft is the little piece of paper and 1 straw. And this is going to be a simple lesson in thrust. So we're going to take our paper, put your finger in the middle on one side, and kind of roll these sides in so that you end up with a point like this. Kind of looks like a paper airplane, doesn't it? And take a piece of tape and just tape this together. So try to keep this end really tight so not much air gets out. That's the most important part right here. So maybe even put your tape right up on the end and tape this together. And I'm going to need another piece to hold this end together. This is super simple craft. Now we have created a little rocket or something here.
Looks kind of like a rocket.
So we're going to demonstrate thrust. This is to talk about what thrust is. And we, the human, in our lung capacity, are the energy that's going to make this work with this experiment. And then Captain Krueger is going to explain how it works on an airplane. So you're just going to simply put that on there and blow it. And it flew across the room because I gave it the energy from my lung capacity, the wind energy, to move it. So do you want to talk about thrust on an airplane?
Okay. Now you notice these, all these are jet engines. Now the B-52 had 8 of them. So 8 jet engines. The 737 has 2. The B-1 bomber had 4.
Well, they're smaller here, aren't they? Underneath there.
Well, they were quite big.
Oh, they're big. I see.
Remember,
I'm just seeing the end.
Right.
Okay.
The B-1 was designed as a low-level, high-speed bomber, so they tucked those engines in tight.
Yeah, they're right
to
up
cut down the drag. But how does a jet engine produce thrust? So you saw what Michelle just did. By producing thrust to the piece of paper, it flew across the room. So how do we produce thrust to get these airplanes to fly down the runway to generate enough lift to lift off the ground? Well, what a jet engine does, it takes the air, and in front of a jet engine, we have what they call as a compressor. And they look like actual wings. Okay? And what that does, it compresses the air. Then the air gets mixed with fuel. It's ignited and then blown out the back of the airplane.
It creates the energy that way through the engine. Okay.
Right? In the back of the engine are turbines, and that's what causes the compressors to move. Okay. So that's so we compress the air, we mix it with fuel, Jet A, which is very much like diesel fuel. Okay. We ignite it, and then it blows out the back, and that's what creates the thrust to propel these airplanes.
So that gets them started down the runway, and then the wing starts generating that low pressure, and the lift happens.
And that's how the lift happens on there.
Very cool. So that was a simple craft on thrust. Now we're going to talk a little bit differently about this kind of airplane right here. It's a helicopter. And in your kit, you have an air spinner. And it's another kind of wing. So we're just going to cut one out. You have it in your kit. They look like this. And we gave you two because two fit on the paper. So I'm just going to cut one of these out. Do not cut this line right here. And cut the outside line down on the bottom. Okay, so see it says do not cut. That's a fold line. Okay, so let me get this cut out real quick. And we'll talk about how these work. I think it's super interesting to learn how these things work because when I do fly, I'm always looking out my window at the other planes before we take off. And so it's really neat to learn what the parts are and what they do in making planes fly. So thank you for explaining that, how that works. Okay, now this is also tricky. I've cut out the outside, but you also need to cut up the center between these two spaces all the way to the dot and no further than the dot. See that? Now what we're gonna do is on this foldy line, where the dotted line is, you're going to try to fold it as straight as you can here. And then this one, take the top and fold it this way. And so we've done this. So it kind of looks like someone doing the splits, doesn't it? Then we're going to fold this top down. And I'm not sure if it matters which side you fold towards. Just fold it in half so that the top hits the bottom there. And now we have created something that exists in nature. There's a tree that makes these. And they have a spinner that goes down. So we also need a little weight to make it happen. Just like on the glider. Make it a little more stable. A little more stable. Okay, I've given Captain Krueger one too, so we're gonna try these. So what happens when I drop it? Oh, mine went straight down. Oh.
Okay.
So you fold my things. Let's see what happens when I drop it higher.
Well, let me try it here.
Let's have Captain Krueger try it and see what happens.
So I'm going to drop it just straight down with the paper clip down.
On the down.
Okay, but notice it started to spin because we started to develop lift, which caused the rotation and the spin. Okay? But now I'm going to add a spin to it by twisting it. And you should notice that it's going to fall a little bit slower. Okay, see if I can get that.
Oh, it did fall a lot slower.
Right?
Yeah.
Okay, so that's what a helicopter's doing. Mm-hmm. So a helicopter, basically 2 or 4 blades, right? Okay, and these are wings. So this particular helicopter, I believe it's an Apache Army helicopter, has jet engines that rather than blowing thrust out the back, through gearing, they cause these propellers to turn. And as these propellers turn, they generate lift to lift the helicopter off the ground. So the helicopter doesn't have to move forward to generate that lift on there. So it can, that's why it can lift straight off the ground.
That's really neat. So
now, let me just say one more thing. People ask, well, why is this goofy thing back here?
Yeah, why is there another propeller?
Okay. There was a guy by the name of Isaac Newton that developed this, said for every action, there's an equal and opposite reaction.
Correct, yeah.
Okay. So as these propellers are turning, if I could grab the propeller and stop it, the helicopter would just twist around like that in the opposite direction. So what this does, because they're creating so much torque to turn the helicopter, this back propeller stops that.
It puts an equal force
in the opposite direction of what it when it spins. And also, okay, in an airplane, you have rudders. Okay, so when a pilot's flying, he's pushing those pedals to move the rudder back and forth. So rather than having a horizontal wing, you have a vertical wing and the back part moves back and forth, and that's how we turn the airplane in the air.
So this piece right here actually goes side to side.
In the back of it.
In the back of it. Just
in the back of it. So there's a hinge in the back of it to change the shape of that wing to move the airplane left or right.
Okay.
In a helicopter, what he does to move it left and right, if he's in a hover mode, he changes the shape of these back propellers. Okay, so he has rudder pedals too, rather than just these change shape, which either they produce more thrust or less thrust to turn the helicopter.
So it's not just equal, would be going straight. You add more, you would turn one way, or give it a little less, you're going to turn the other way.
Remember I said without this, the helicopter just wants to twist.
Right.
So he changes the shape of these, changes the camber of them on it, right? Changes the shape, and then he can turn the helicopter left or right.
That's really neat. Thank you for explaining that.
So one more thing.
Yeah.
So a lot of you have probably seen the windmills now that you see that are producing energy. And I know, Michelle,
the giant wind blades.
The giant wind blades. And some of them we know, a lot of them are made right here in Windsor, Colorado.
Correct. And they move on the rail right here by the museum. They transport them by rail.
Okay, so, and now we know that those are producing electricity. And I know Michelle has had a previous episode on electricity. So exactly the same thing. Notice when I dropped this, it started to turn. Okay, I'm not going to twist it this time. See if I can get it to turn a little bit there. So now with those wind blades, you're doing the same thing. You're taking a wing, and this time rather than using thrust, you're just allowing the wind to create lift on those blades. Just like I said, a high pressure, low pressure. Okay, so now with the high pressure on one side and the low pressure on the other side, those wind blades turn. Okay, and inside there,
and then that creates the electricity.
Right, inside there is a generator that creates electricity.
Because you remember we talked about energy is always conserved, so wind energy is turned into electric energy.
Or turned to electrical energy.
That's really neat. That really explained. And I guess I hadn't thought about those being wings before on a windmill, but they're a wing.
All wings. They all are wings.
That's really neat.
When you see a sailboat move, when a sailboat, you're taking a sail and trying to shape it, and I love sailing, and you're trying to take a sail and shape it to make it into a wing, to produce thrust.
That's really neat. We have one more craft we're going to do. This one, you're going to use your tall sheet of paper, and you might want to pull out the wing that we made in the first lesson. So what I'm going to do is take my ruler, and you need 1 inch wide. So we need one that's 1 inch wide and 10 inches long, and 1 inch wide and 5 inches long. So I'm just going to measure over 1 inch and make a mark. And I'm going to do this down my paper. And then this is, because I'm not always great at making an exactly straight line, I found that if I make enough marks, I can take the ruler, line it up on all the marks, and I get a nice straight line. Like that. Then I need to make sure I have 10 inches long. So I'm starting here, and here is 10 inches. So I'm going to make a mark here. And then I'm going to do it right on the edge. So I have at least 2 points here. And then I can draw my straight line here across those 2 points to the edge. Now I need to measure over 1 more inch and do exactly the same thing again. And I'm just going to leave that line so I only make one cut, and I'm cutting both pieces apart. So I just need to come over 1 more inch here. And you notice my ruler doesn't start at the edge, it starts right at the line inside. So you have to check your ruler. Sometimes, I don't know if you can see that, but my ruler actually starts right here instead of just the edge of the ruler. So you've got to always watch that when you're making measurements. So I'm going to make a mark. Do it again about here. And then 1 more here. And then I'm going to draw that straight line again. Lining up all those dots. And now I'm going to measure down 5 inches here. And then I'm going to do it here in the middle and here on the edge. So I have 3 points to draw across. Make sure I get it straight. Here we go. Now I'm going to cut out this piece and this piece. And we're going to use them to make our wing a little stronger. Yeah, this is going to be fun. It's a whole different design of wing, but really kind of what we're building is the tail to a wing. I think is how we're going to find that
Trying
works
to make
out.
trying to make the flying wing
more stable.
a little more stable.
So what we're going to do now is we've got a 10-inch and a 5-inch, and I'm going to make them into a ring by wrapping around. Get the tape out a little bit closer here. So wrap it around and tape it into a circle. I found it was easier to do this first before I tried to tape it to the straw. Otherwise, I was trying to hold too many things at one time, and that didn't work as well. You don't have to be super exact as to how much you overlap. I chose about 1/4 inch to 1/2 inch. Now we're going to take this other straw that you have and tape one to one end and one to the other. This one I found was a little bit more difficult, and it worked better if I had a longer piece of tape, like a couple inches. Put it down on top of the straw in the center, and then I took my fingernail and kind of tipped it down tight against the paper. And mine went on a little crooked, but that's okay. That gets it on there. Now you can tape it a little more stable too. Let me put it on the other end. Same thing, but this one's a little harder because it's smaller to get the tape inside there. And hold it right on the end. Sorry, I hope you can see that. See, and I take my fingernail and just push that down so it's nice and tight on there. Uh-oh, this one's crooked. Can you see that? That's going to be a problem, so I'm going to have to redo that. And that happens, but you want to make sure that you get it straight. So I'm going to untape that and fix it because I know that's going to fly a little better. The little one's definitely the hardest one to get on really straight. So try one more time here, holding it as straight as I can and tape it down. Okay, so now I've got it straight. Now I also have to have them in line this way. Do you see that? So this one's not down here while this one's up. They need to be on the same side of the straw. And so if you need to pull it off and retape it again, do it so that you can get it, because it's going to fly better if you have it nice and straight. Okay, this will actually fly on its own if you have a lot of space, like from pretty high. If you have a staircase that you could throw it off of, and we can't really demonstrate that here and let you see that, but it will eventually kind of spin and fly. But Captain Krueger has an idea for this that I think is going to make it fly a lot better. So what do you think?
Well, okay, so you've created a tail for stability. We can take our previous wing.
Right.
And let me have some
Would
tape.
you like some tape?
Okay, so we're going to tape it on there. And I'm going to try it from the top. Plus it looks cool this way.
It does look cool.
Okay, so we're trying to keep this all straight.
I think this came out on.
Okay. Now you can experiment, and we probably want to add a little bit of weight
Do you
to the
need some
front.
paper clips? I have another star one too.
That might not fit on here. Let's try this one.
I also have little paper clips too.
There we go.
Oh, I see a little weight in the front.
A little bit of weight in the front. Okay. Now what we're trying to do, remember I said how the wing was so unstable? We're trying to see if we can make it more stable by adding a nose. Well, we'll call this just like the tail.
Yeah.
And some airplanes do have this, a wing in the front. They call that a canard on an airplane that has a wing in the front. Let's see how it works. Oh, probably a little bit too much weight.
Too much weight? I will go get it. Yes. let's try it again. Okay.
Okay. Let's try a little bit of a lighter one.
I have a small paper clip.
Let's try that.
Okay.
Now you can also play with where the wing is. Experiment by moving the wing forward or back.
Oh, good point.
Let's call this the fuselage, just like here, right? Okay, so you can move it back and forth. The straw we'll call the fuselage, and see how that does. There we go.
It lifted. It
It
went
actually
up.
lifted up. So
That
now
was
we probably with a
wonderful.
little bit more weight, or move the wing forward to get more weight forward.
Okay. Because then
But
it went up.
but you can
and-
see it actually definitely lifted. So we had probably were generating a little bit too much lift up here. Or you could change it around. You could change it so it's this way and try that. And switch your wing around and see how that does. So what you're trying to do is balance all these forces, just like the main wing, right? The rudder, what we call the vertical wing, or the tail, and the horizontal wing. Okay, so that's what you're trying to do here, is find that balance to get it to fly. I'll point it down a little bit this time. Oh, see, so that's the thing. So you're learning aerodynamics
Yeah.
on how that works and the
That's
balance
awesome.
of the airplane.
I would get it one more time because it's so pretty. We'll have it in here. Well, thank you so much for showing us all of the things about flight. I hope that you really enjoyed the show. I have. I learned something today. So I didn't ever think about windmills being wings.
That's exactly what they are.
Yeah, and that absolutely makes sense. It's the same principles of physics that apply to that. So thank you for joining us. We hope you have fun. Experiment and try lots of different things and let us know what you think. You can find us on Facebook if you want to post some of your pictures. Thank you, Captain Krueger, for being with us.
I'm glad to be here. It was a lot of fun.
Thanks. We'll see you next time.